Rhonda Schwartz, and I'm going to be the moderator for the webinar today. We're excited to launch the BD2K Standards Coordinating Center's webinar series with the first talk given today by Dr. Chris Chute. And he'll be talking to us today about comparability and consistency of clinical data, the ICD-11 initiative. After 20 years at the Mayo Clinic as the founding chair of biomedical informatics, Dr. Chute joined Johns Hopkins University, where he is a Bloomberg Distinguished Professor. He is well regarded for his work in biomedical terminologies and health IT standards, and he chairs the World Health Organization Revision Steering Group for the revision of the International Classification of Diseases, ICD-11. I want to thank Dr. Chute for his partnership in communicating information about this emerging standard. It seems really that ICD-10 just recently has been implemented back in October of last year. So I'm curious to hear where we are right now with ICD-11. Before I pass control of the slides to Dr. Chute, I just want to remind you all to put yourselves on mute to avoid background noises. We'd really like to hear from all of you. We want to include your voice in the conversation, so please, ask questions, share your comments. We're going to have a Q&A period at the end. Please note that this session is being recorded and will be made available for future use. So at this point, I'm just going to hand it over to Dr. Chute. Thank you.
Thank you very much, and I appreciate the opportunity to share some observations with you. Let me move on to my disclosures pro forma. Basically, I don't have any, other than I have a very odd sense of humor, but in terms of IP and other types of things, there's really nothing proprietary about this. Let me start with an assertion I often make, and whether we like it or not, healthcare, particularly as it's practiced today, has become a profoundly information-intensive industry. And here we see a list of things we do in healthcare or try to do: control costs, improve quality of outcomes, and so on. Compassionate resource management, of course, is code for saving money. We don't say that, but it really means. And if we want to do any of these things, if we want to do them well, if we want to do them effectively in a data-driven way, then obviously it depends fundamentally upon information and ultimately patient data. And I would add that biomedical discovery is really one of the core technologies and mechanisms of improving healthcare quality and outcomes, and thus quite relevant to BD2K. This is an old slide, but I think it illustrates the way most of us have thought about health data historically. If you see the hot sun in the middle, that's supposed to be the solar system, trust me on that. The hot sun was the billable diagnosis, and if you didn't cut a bill, then, well, what good were you in terms of IT and healthcare? And notions of clinical data, of course, were floating off in the void. What we try to achieve, and I think for the most part have been relatively successful over the past 20-odd years, is a recentering of the way we think about health information, refocusing on clinical data and making that hot sun the center of our solar system, actually the data itself, with derivatives such as bills and scientific literature and research and guidelines and accountable care operating principles in a way that focuses our attention on the clinical data and, I might add, the consistency, comparability, and usability of that underlying data. This is, as I tell many people, my trademark slide. I show this at every talk I ever give, whether it's relevant or not. I think it's actually relevant today, but basically if we trace this cycle, this virtuous cycle, if we accept that everything fundamentally begins with a patient, and I might add this also again pertains to discovery science, even if we're talking about biospecimens or other kinds of investigational parameters of patient data rather than just the electronic health record data, it still begins with the data. And if we're clever, we go around this circle. The names in the boxes don't really mean that much, but you get the general idea. We generate medical knowledge from observational data through data and inferencing. We could say we're done, get tenure, and go home, but if we're conscientious, then we reinsert that medical knowledge into the healthcare process. And again, the whole notions of knowledge management, decision support are well documented and well understood. But the question I'm asking is, all right, this is a virtuous cycle. We see data being generated and knowledge being derived from it and reinstilled in the process. But how do we make this circle go faster? And more importantly, how do we ensure continuity and consistency across the stages of that circle? And in my mind, this comes down to the central core, the hub around which this wheel turns, this samsara, this discovery. And that's really fundamentally based on comparable and consistent renderings of data, which arguably we can call standards. Now, I focus on terminology and data models because, at least in healthcare, those are the tangible manifestations of interoperability at the level of patient data and patient information. We could make arguments to extend that, but I think you get the basic idea. Without comparable and consistent ways of rendering this data, we insert all kinds of dissonant obstacles in our path to discover knowledge from data. Well, this being a BD2K webinar, I'd be remiss if I didn't have a BD2K slide, but I mean, you get the idea of discovery and trying to generate information in a way that creates a data commons, creates a data environment that can truly interoperate and leverage and accelerate translational research. I realize that today is the one-year anniversary of this perspective piece in the New England Journal, and also the day that Dr. Collins is at the White House again to announce the award of the Precision Medicine Initiative pilot grant to Vanderbilt. That's, I think, a well-deserved recognition. But again, the whole principle of precision medicine, the notion that we can have 1 million persons and generate data from which we can learn, is in turn going to depend fundamentally on the data underpinning that cohort having comparability and consistency so that analyses can effectively carry forward. Well, I've written about this topic, some rantings of opportunities for big data in healthcare. It's not an old topic, but it is an old idea if we think about how to leverage data to really change the world. This is my friend Galileo. You'll discover through this talk that many of my friends are actually from the 18th and 19th centuries. Galileo, of course, is from the 16th century. This is his diagram of the moons of Jupiter. You can see Jupiter here, the bright star, and the various moons in different configurations. Not a huge amount of data, I mean, just some scribblings on a sheet, but this was big data for its era, in that it fundamentally changed the way we think of ourselves in the universe and the way we think about our place in the world. So it was quite influential. It's hard, however, these days to take a $3 telescope out in the backyard and change the world. Here is a modern-day rendition, if you will, of the same notion. This is the Sloan Digital Sky Survey, probably the largest big data repository of astronomical data operating today. You can see they have over 1 billion objects, 260 million stars, 208 million galaxies, each of which has a fairly sophisticated data structure underneath it, of spectra, of images, of metadata, and the like. So this is astronomy in the 21st century, and a very different thing indeed from Galileo. Correspondingly, if we look at Rutherford, the last tabletop experiment, I think, in physics, where we really encountered the whole notion of a quantum theory of the atom, of having not a plum pudding model, but rather a nucleus, and a very dense nucleus at that. That was the point of this gold foil experiment, where, much to his surprise, radiation bounced off at very high angles, suggesting a very small and dense center to atoms. Well, great science done on a tabletop. By the way, that tabletop is still radioactive at Manchester, they tell me. But if we look at science today at Higgs boson, we're doing it at a completely different scale. 10,000 scientists, only 2 Nobel Prizes, sadly. 200 petabyte of data, $13 billion price tag. a big deal, and the notion of doing cutting-edge physics on the tabletop is perhaps not as common as it was at the turn of the last century. Well, let's think about that Higgs boson thing. Really, their big data is almost, they can almost cheat, because at the end of the day they're dealing with mass energy, which is the same thing, direction, and charge, and not a whole large number of other parameters around those particles that they're tracking. And I would argue that biology and medicine is a tad more complicated than that. And it begs the question about our nature of big data and our nature of information, the way we think about it. We could characterize big data really into broad and deep categories.
Hello?
If we think of broad categories...
You can still working on it.
Hello? Broad and deep categories, so that we have the notion of, for example, claims data, very, very broad data, but relatively shallow. The amount of information on each patient in a claims database is limited to a handful of administrative parameters. Or we could talk about deep data, the number of whole genome sequences on the planet today is probably in excess of a couple of 100,000, changed dramatically from a year ago, but it's still very deep data, a lot of data for each observation, relatively few observations compared to claims data. And the problem is that healthcare is both broad and deep. If we look at clinical phenotyping from electronic medical records, the whole notion of laboratories, vitals, I mean, you see the laundry list there, never mind social, environmental, diet, and other impacts on the healthcare process, bring in the omics world, and we have a problem with deep data and broad data in healthcare that really is unparalleled, I think, in most other fields, and makes biology and medicine a difficult target for leveraging big data machinery and infrastructure. So the question is, what can we do to make that more easy, more straightforward? And the mantra of my talk, of course, is that comparable and consistent renderings of data, in this case semantics, are really crucial to having an ability to analyze across, to leverage that breadth and that depth in a way that we can harness it analytically. And the counterpoint is that without underlying terminology or ontology.
Actually, there is no response issue. I responded numerous times.
For somebody who is talking, if they could mute their phone, that would be helpful. Thank you. And the counterpoints being that if healthcare isn't comparable, the data isn't comparable, then it's very hard to interchange data. It's very hard to do research on the data without throwing armies of abstractors to normalize the data into some protocol-specific rendering, which does not scale when we're talking about big data and BD2K kind of methodologies. The whole notion of adjusting requires a richness and breadth, because if we look at even a very, very large database, as soon as we stratify across different socioeconomic, demographic, pre-existing medical history, we get into small number problems very quickly, which means we really do need the richness and depth of the data at its source to the extent practical. Well, here's some historical paradigm for you. This is the London Bills of Mortality, or at least a treatise written on it about 100 years after it was formed. The London Bills were really started by Henry VIII in the 1500s, and by the 18th century, we had, 17th century, we had John of Gaunt writing about them. This was the Mayo Clinic's copy. I was kind of bummed that they only had the 3rd edition, but it turns out it has way better foldouts in the back. And here's an example of those foldouts, the table of causality, where we started to quantitatively tabulate cause of death over time. You can see years here, that John was tabulating. I call this a 16th century data spreadsheet. Some of the categories are a bit odd. My favorite is really found dead in the streets. I don't know what the underlying pathophysiology or genomic contributions to that might be, but still we're seeing a quantitative approach to categorizing data, cataloging it into consistent categories in a way that we can start to make sense of it. And from this relatively rough data, notions of epidemic disease, notions of endemic disease started to be recognized. Obviously, the whole notion of location and small area variation started to be recognized. And remember, the reason that this was done was so that the king didn't have to go where the Black Death was. It was to figure out where the people were dying. Well, this moved along in the British tradition several hundred years later. William Farr, you remember him, as really one of the founders of British epidemiology, said, look, the naming problem is as much important in this health world as weights and measures are in the physical sciences. And the argument was, how can you do physics without the notion of a gram or a second or a meter? How can you do chemistry without a periodic table? And indeed, how can you understand health data without comparability and consistency in the nomenclature in the way we name and categorize elements of healthcare and disease? And that brought about really the onset of the ICD. John later on went to create the first ICD in 1855. Well, we analyzed probably 20-odd years ago questions of how well clinical classifications work. I mean, they're not in very high repute among many researchers and academics, and I think with reason. So we looked at this systematically, and we republished this probably 2 or 3 years ago in Health Affairs when ICD-10 became more aware in the United States. You have to understand, ICD-10 was introduced in 1990, so it's over 25 years old already. Even though the United States just adopted it last year, it's a really very old classification. And the question that we looked at in our Health Affairs paper was, how well does ICD-10 compare to ICD-9 in terms of information capture and coverage? And so this is an arbitrary 0 to 2 scale. I won't bore you with the details of how the metric was generated, but the point is, if you look at it just graphically, ICD-9 and ICD-10 are probably neck and neck in terms of their ability to capture information. So ICD-10 does not bring us a great benefit or value in terms of its information capture or coverage. And furthermore, if you look at this gap, so this is overall over 3,000 odd cases that we looked at, if the amount of information that is not captured by ICD-9 or ICD-10 is really quite large. And I think this is most of the reason why many researchers are suspect of analyses that are done just on health services research data, just done on claims data, ignoring the issues of upcoding, simply because the underpinning classifications don't have the resolution or granularity to capture a lot of the concepts that are relevant in healthcare data. Now, we'll talk a little bit about SNOMED at the end, because one of the counter arguments is, well, why are we trying to do it in a classification? Why don't we just use SNOMED, which is more of a terminology than a classification, and that's accurate, but I'll address that point to some extent. It raised the question of whether we should rethink what an international classification is and whether it should remain a 16th century data spreadsheet, because the architecture and structure of the ICD really has not changed since its creation in the 1500s. And the notion that we looked at when we created ICD-11 was, gosh, let's try to make scientific consensus of clinical phenotype a primary use case. We see all too often in something like ICD where you have myocardial infarction and a code number, or infralateral myocardial infarction, but there's no definition. The interpretation of what a myocardial infarction is left to the reader, is left to the coder. There's case precedent, there's even reimbursement case law, but it doesn't come out of WHO and it doesn't come out of the classification per se. So clarity on what the clinical phenotype that we're talking about was considered an important goal. The traditional metrics or use cases of public health surveillance, data aggregation is used very extensively in clinical operations and quality operations, not to mention this little reimbursement thing that had largely been ignored by the developers of the ICD, although it's obviously an important current use as we evolve in this current reimbursed era. Well, traditionally, the ICD, by design, was a mutually exclusive and exhaustive classification. That means that we have a mono-hierarchy as the underlying structure of the ICD. That's not an oversight that was deliberate. The idea is if this is, let's say, gastric cancer, then it's allowed to be a cancer, but gastric cancer is not allowed to be a GI disease, for example. And that seems arbitrary, and it is, but it's a problem or a requirement of a statistical classification which is mutually exclusive. That means you can't count things twice. And as soon as you have a multiple inheritance network, you are at risk of counting things twice because you can navigate the tree in any arbitrary direction. So a monohierarchy was determined really going back to the beginning as the only way of managing this problem in a statistical classification, but that has its consequences. What we did in ICD-11 is we broke that, obviously, and here's a cartoon of relationships and associations, and you can see the color arcs go across the hierarchy, so we still have that black backbone monohierarchy, but we've interlaced it with multiple relationships and extensions, and furthermore, we've extended the depth of the semantic network that creates what we call the foundation component. So ICD-11 is built on a polyhierarchy semantic network where each node is no longer just a string, but each node has a small information model, and these are some of the elements in that information model: a unique resource identifier, fully specified name, definitions, well, a fully specified definition in text, in English and other languages, index terms, and so on, and some data about the disease entity itself to the extent that it can be captured and cataloged in a systematic way. So this is no longer a single string with a code attached to it, but now a more sophisticated information model with an associated semantic network. Well, I just finished telling you that a statistical classification has to be mutually exclusive, meaning a monohierarchy. So we broke it. What are we going to do about that? And what we're going to do about that is introduce something called a linearization. Now this, of course, is ICD-10 codes, but it still illustrates the principle of a linearization, where we have this polyhierarchy, this semantic network, and we derive from it a serialized form, which essentially walks the tree as a monohierarchy. So it more or less recreates the black backbone that you saw. That is then mutually exclusive and exhaustive. And at this point, you're no doubt mightily impressed that we took a simple problem, made it horribly complex, and then, of course, derived a simple derivative from it back where we started from. And the question is, why did we go through all that fuss and bother of creating a semantic network if in the end we're going to have this linearization that walks and talks and looks like all the ICDs of all time? That seems like a huge waste. And it would be if it were not for the fact that if we can create a single linearization, we can actually create an arbitrary number of them. We can create linearization for morbidity, for quality, for reimbursement, for public health, and they all derive from the same foundation component, the same foundation semantic network, and they can all interoperate and interrelate because they derive from the common semantic source. So if we contrast these things, there are really two major components that I'm talking about at the moment, and there's a third I'll introduce later. The foundation component, which is the semantic networking, and this I'm hinting at the third, which is the common ontology. It has an ontological scaffolding, and I'll talk about the common ontology with SNOMED at the end. It has a content model. It has meaningless identifiers. It's potentially huge, and it can be updated very rapidly in real time. From this, derive periodically, annually, whatever, a number of linearizations. And those linearizations are always, by definition, mutually exclusive. They always have a single parent hierarchy. They're exhaustive. They introduce residual categories, things like not elsewhere classified or not otherwise specified, which, if you remember the Semino desiderata about terminologies, are supposed to be bad for you, but they are a feature of statistical classifications. You must have a place to put everything. That's what we mean by exhaustive. So mutually exclusive and exhaustive defines the concept of a statistical classification. They derive from the foundation component, so they inherit the content model. They have stable versions by design. Now, it turns out that the traditional community in the classification world, I think reasonably, wanted something more familiar that looked and sounded more like ICD-10, just so we didn't have this dissonance with the user community. And we have created at WHO something called the Joint Linearization for Morbidity and Mortality Statistics. It is a linearization, or affectionately JLIMS. It was petitioned by the morbidity and mortality community that they wanted a single linearization, not two separate linearizations, one for morbidity and one for mortality. It turns out that the JLIMS actually has two dimensions to it, so it's effectively two linearizations, but it will be the face of ICD-11 for the statistical community. It shares codes, quasi-autonomous specification, and it introduces something called post-coordination. So this implies that it has a boundary of pre-coordinated terms that we call the shoreline. There are distinctions between the morbidity and mortality use case, specifically post-coordination, which means combining multiple codes into a single cluster, is allowed for morbidity. For example, if you have prostate cancer, and I used to talk in talks I've given on ICD about how my father died of widely metastatic prostate cancer, which is true, but he still had the same code as a man who had an incidental finding following transurethral resection. Well, in ICD-11, we can introduce a severity axis so that we can post-coordinate prostate cancer with a severity, indicate that it's effectively a stage 4 tumor, much like IC O for oncology does presently, and we can designate some rubrics that are specific for morbidity or specific for mortality, which is why we are effectively dealing with nuanced independence of these linearizations. We can also, and indeed are, creating a primary care linearization that's more shallow than the joint linearization for morbidity and mortality. It's not completed, and there's still debate raging of whether it should be a proper subset, that is truncating digits of the joint linearization, or whether we can break with that simple digit truncation, because it turns out primary care clinicians want to lump some things but not lump other things, and it doesn't make sense to slavishly assign it to a proper linearization, particularly when the information model behind the semantic network of the ICD-11 allows you to do both. So, and that's what I'm saying here. ICD-11 linearizations do not need to share the same hierarchy as the joint linearization, but they can have their own walking of the tree, if you will, as long as any derivative linearization at the end of the day is mutually exclusive. So in my cancer example, gastric cancer, let's say we had a gastrointestinal subspecialty linearization, then we can put gastric cancer into that linearization, even though it's in the cancer chapter in the joint linearization, because there's no need really to constrain to the arbitrary structure of the joint linearization when any derivative will be computable. So what are some other linearizations for discovery and quality that we can think of? Well, quality improvement, now these do not yet exist, but they can, the machinery to generate them is in place. For quality improvement, clinical decision support, I mean, you can read the list. And indeed, precision medicine discovery and implementation, translational research, BD2K style integration with basic research data and clinical phenotype. All of those can be derived from the underlying ICD-11 foundation. And it's an interesting question what the WHO intellectual property rights will be around derivative classification. I think their intention is to make this a public good. That's certainly been their heritage, even though the ICD has been a large market in the United States, particularly for publications and the like. Just a word about digit enumeration. These are different base models. So this is an example ICD-11 code. You can see it's mixed alphanumeric, where we try to mix base 34 numbers, where we exclude O and I, use the letters and accept O and I, and then 0 to 9. We don't want to confuse with 0 and 1, of course. So that's a base 34 number, so we have a lot of base 34 numbers. We have a base 24 number, which is no numbers, to always indicate the distinction between an ICD-11 code and all other classifications, because it's not possible to have a letter digit in the second place in the other classifications. And then, of course, the notion of this cluster digit. The 7th digit is a special case, which really carries an information model. It is a very trivial grammar around combining information. It's also used to render the residual categories of otherwise specified or unspecified, as we've historically known them, or the 8s and 9s in the old classification. Well, I've been a terminology guy most of my career, and I was finally persuaded that terminology isn't everything, that structure and context actually matter. So the whole notion of words, findings, and interventions having context with a multitude of structures around that context that need to be accommodated. So if we look at in this case, an information model, a trivial information model, we just drew a box around the word heart disease, and then we put a label on it. We call it family history. We fundamentally transform the semantics of this rendering. That heart disease is now no longer a patient with heart disease, but is somebody that has a family history of somebody with heart disease, which is a different concept. So we can fundamentally change the semantics of an assertion by information models within which they exist, by their context. And we can do the same darn thing with a terminology model where we prepend or make a traditional pre-coordinated expression into a post-coordinated expression, and we have this whole notion of having an ability to render them either way. So this is the pre-coordinated, this is the pre-coordinated model, this is a post-coordinated model, but they're really saying the same darn thing, and the issue is how do we recognize that? Well, in ICD-11, we introduced what I call the trivial grammar, which is this clustering notion that I referred to before, where we can have, in this case, diabetes. We can say that it's associated with diabetic retinopathy, that it's associated with chronic kidney disease, using these cluster digits. And furthermore, we can subcluster that the kidney disease associated with the diabetes also happens to be stage 4, and the peripheral neuropathy associated with the diabetes also happens to be grade 3. These are clustered because of the Ks. The kidney disease and stage are clustered because of the As, and they're all clustered together because of this cheat sheet where 1, A, and K always travel together, and you can see the logic here. A trivial grammar, kind of a forced rendering, but it does allow us to combine an arbitrary number of modifiers with an underlying disease concept, and furthermore to subcluster those modifiers in a way that we can actually create fairly rich expressions of clinical reality and clinical findings in ICD using traditional 7-digit codes without breaking the machinery that is used for ICD today. Let me just close saying that, you know, there's a strong flavor of SNOMED in what I've been talking about, particularly post-coordination and pre-coordination and semantic backbones. And this was recognized a long time ago. That in 2007 we said, look, SNOMED is going to need high-level nodes to aggregate the clinical data. Sounds a lot like ICD. And that ICD-11 is going to require an underpinning terminology, the semantic network, the foundation component. Sounds a lot like SNOMED. And we signed in 2010 a memorandum of agreement allowing cooperation between and among them. The way we saw it in 2007 was that if we weren't careful, ICD-11 would create up a SNOMED wannabe. And that SNOMED would have this aggregation layer that would kind of be an ICD wannabe, and that we'd be competing. And that was, of course, agreed to be an undesirable situation and circumstance. And so what we did is that in 2007, we envisioned that it would make sense if we made the aggregation layer or the classification layer of SNOMED become ICD by definition, and the extensions of ICD become SNOMED by definition, and then we could have our linearizations as I've modeled them otherwise. That was a good aspiration, but it turned out to be a very naive concept for lots of reasons. First of all, SNOMED is built on a description logic. ICD is more of a simpler information model that is not in any way, shape, or form created by a description logic. So we came up with this notion several years ago of generating a common ontology between and among ICD and SNOMED. So this is the third component of the ICD-11 project, a joint effort between WHO and IHTSTO. It is more or less a subset of SNOMED that provides the semantic anchoring of the foundation component or the semantic backbone for ICD-11. And the principle is that the ICD-11 foundation components elements will be defined by query expressions against that common ontology. And I'm very explicit about this syntax. This is not a description logic. This is a different set logic theory. Description logics have the problem that they are, by definition, always true or false. The whole notion of description logics and OWL and all those really don't deal very well with probability, or you know, a patient may have chest pain with their myocardial infarction, but they don't always. You can have such a thing as a silent myocardial infarction. Well, description logics don't deal very well with things that are usually true but not always. They only deal with things that are always true, which is why we came up with a more relaxed logical environment of the query expressions that I'll show by illustration. So the common ontology is a subset of SNOMED. So there's our SNOMED cloud. Here's our foundation layer in ICD-11 with mirroring the same common ontology as its backbone. And the idea is that if we have complex expressions, for example, hypertension excluding pregnancy or preeclampsia effectively, instead of representing that as a description logic, which is a negation, and that's EL++, which is the SNOMED description logic, and even OWL1 had trouble with negation. OWL2 is less, can handle it, but not as well. So we dealt with a very, very simple SQL-like logic, where we used a query notation, where we select the cases of hypertension, and we subtract, effectively, those persons who are pregnant simplistically to create hypertension of pregnancy as the counterpoint. This is regular hypertension, and this is the hypertension including the pregnancy, again using simple set-relation theory as rendered in SQL-style query. So this is my last slide. Where where is this going? Biomedical practice and research are very information intensive. I don't think I have to make that case too aggressively to this crowd. But nevertheless, to manage this knowledge in its breadth and its depth, in its profound richness in the biomedical space, we must strive to either generate or transform the information into comparable and consistent renderings. That it's a prerequisite for efficient clinical analytics. You can't put something into a model unless you've normalized it. You know, biostatisticians spend 90% of their time cleaning dirty data, and it's really an instance of making it comparable and consistent. To do that more efficiently, it would be handy if we all hummed around the same data standard, and I'll tip my hat. I think the FHIR standard, the FHIR, Fast Healthcare Interoperability Resources, are rapidly emerging as a very, very strong candidate for a canonical standard in biomedicine and healthcare today. Obviously, they handle clinical data, and increasingly there was a paper out of Zach Kowane's group last summer looking at the genomic applications of FHIR. Meanwhile, ICD-11, which I hope to really become a 21st century artifact, breaks a lot of the traditions that have been with us since the 16th century, but still honors the requirements of statistical classification, while at the same time maintaining a semantic network. I should hasten to add at the end that this common ontology that I described is still a work in progress. The common ontology partnership with SNOMED is not complete, but and we think it will take some more time to complete after the publication of the joint linearization in 2018. But it is still, nevertheless, a process that more or less shows a way to have a robust semantic scaffolding for clinical concepts used in healthcare and strong potential for linkages to basic science, which I think is important to the BD2K community. So with that, I'll take questions. Rhonda, do you want to navigate the, see if people are raising hands or something?
Sure. Does anybody have any questions right now? One question that I had. Go ahead.
So this is Jessica Tannenbaum. I'm not online because I was walking, but thanks, Chris, for that. It was very interesting and informative. I was curious about the sort of culture of building ICD-11. I'm just naive in this. Is it a funded project? Like, who pays for it? Is it just from whoever shows up? Is it a profession to be an ICD-11 developer? How does that work?
The ICD-11 development is managed and coordinated and owned by the World Health Organization. The World Health Organization has some modest funding from the Japan Hospital Association and other donors, as well as some core WHO funding to maintain it. But frankly, if you compare the annual budget of SNOMED to the annual budget of ICD, it's about a 20th the size of SNOMED. It is not a very well-funded activity. And I should disclose that I've been at this role for, well, since 2007, and I've received no salary support that entire time. I kind of regard it the same way I regard, participation in other standards organizations. Nobody pays me to do that. My HL7 work, my study section work, whatever. It's part of being the kind of scientist I'm trying to be. So it is overwhelmingly donated effort. They have tags or topic advisory groups. They have about 16 of them by clinical domain, made up of clinical and basic science experts around the world. Each tag has about 20 members. None of those members are paid either. So it's a labor of love.
Okay, as I suspected. Thank you very much.
Are there any other questions?
Yeah, I have a question. So, with ICD-10, there was the international edition and then the clinical modification for use in the U.S. And I'm wondering what the trajectory of ICD-10 CM versus ICD-11 is for similar kinds of uses here, or if it's intended just to be a new kind of international standard?
Well, that's an excellent question. ICD-10 came out in 1990, and many countries, not just the United States, subsequently made clinical modifications, which effectively means they added digits. The Australians, the Germans, the Canadians, I mean, there are CM equivalents in all those countries. In Canada, it's called 10CA. In Australia, it's called 10AM. I could go on. But the reason they made those modifications is that the detail in ICD-10 was not enough for their domestic use case. If you compare 10CM to 10 vanilla out of WHO, it basically has 2 to 3 extra digits at the end of the number, so there's more detail. The aspiration with 11 is that there really would be no need, particularly with post-coordination. There would be no need for those additional national modifications because the detail is there. And what we're aspiring is that countries will choose to require specific post-coordination or not as a way of building effectively their national rendering of the ICD. The problem with the current model, if you actually compare 10AM, 10CM, 10GM, 10CA, and so on, all these different flavors, there are about 15 of them, they actually get into a fair degree of divergence, semantic divergence, where they're not compatible with each other. And that's a nightmare for international comparability and completely unnecessary. So again, the aspiration is that 11 would obviate the need to create those, and that we'd have a higher probability of generating comparable international statistics.
I mean, do you see, national use of this creating their own single codes to represent these kinds of useful standard post-coordinated things anyway, just because, you're submitting something to Medicare and they want a code, they don't want an expression, presumably. Is that likely to happen anyway, even if it's still semantically,
Well, I mean, if you look at the way the codes are generated, so here's an example of a cluster code where we've got basically a paragraph of information about this diabetes case and the comorbidities associated with it. It's very clear that the root code or the first code is the primary condition, and they may choose to accept just the first code. On the other hand, CMS and everybody else wants to do valid case adjustment, wants to do case mix adjustment and everything else. And the way we do it today is very bizarre. We say, well, if you've got heart failure, and oh, by the way, if you also have heart disease or kidney disease, and you also have liver disease, then gee, your heart failure must be really bad. We do case mix by comorbidity. This would allow doing case mix by explicit severity, by explicit rendering of sequelae and consequences and scope. And it still uses the same machinery. I mean, these all look like, you could put zeros in there, I guess, instead of a dash. But these all look like traditional ICD codes, and that's very deliberate. By the way, there's no code in ICD-11 yet for peripheral neuropathy. That's something I pointed out, which I think is bizarre. Get fixed. But this can be very traditional. You can ignore the grammar and toss away all the comorbid or all the associated findings, or you can use them and leverage them in case mix algorithms that have a much richer substrate. Obviously, this isn't going to be adopted in the United States anytime soon. I think I can speak for many of us who've worked in organizations that suffered the trauma of the ICD-10 conversion, that nobody in this generation wants to live through that again. So when we actually see ICD-11 clinically in the United States is an interesting question. There are ways to create linearizations that look like ICD-10-CM, and I think that will be the pathway where we officially embrace ICD-11, but we create a linearization that walks and talks and looks like ICD-10-CM, and allow that to gracefully evolve into its parent ICD-11.
Thank you.
Are there any other questions?
This is Sherry De Coronado. Thank you, Chris, for that excellent presentation and this discussion. I was wondering, when the common ontology is done, will there be a mapping needed between ICD-11 and SNOMED, or will this effectively be a mapping?
Well, that's a good question, Sherry. And the reason why we're bothering to do this common ontology thing is we want to obviate the very requirement for mapping, given that the whole premise of the common ontology as a semantic anchoring for ICD-11 is that you could, at least in theory, from a body of SNOMED codes, go back through the common ontology, go back through the foundation component, and go to any arbitrary linearization, including the joint linearization for morbidity and mortality statistics, and derive what the correct code for that cluster of SNOMED concepts would be. So it becomes not a mapping, but a dynamic process. And given that, in theory, the ICD-11 codes would be defined in terms of SNOMED concepts and the common ontology, ultimately, at the level of the foundation component, generating those kinds of logic trees would be relatively straightforward. So no, I mean, we all know that maps don't work. Code-to-code mappings inevitably break, have edge cases, have, take our friend hypertension. You just can't map it to ICD hypertension because you have this naughty problem of excluding pregnant women, or at least women with preeclampsia, from that particular category. And a code-to-code map cannot handle that. You really need an underlying logic that has a richer substrate of the patient description to do that kind of transformation.
Thank you.
I have another question. This is Brian. So my understanding is that there's some content development in SNOMED itself in order to support exactly what you were just talking about. I'm curious about how far along that effort is and how confident you are that the content needed in SNOMED will arrive in the, with the logical underpinnings that are needed to do this. Because, I mean, your same point about code-to-code mapping, I could imagine similar kinds of things happening if the modeling weren't exactly right.
Yes, that's correct. And when Ken Spockman was still at SNOMED, he was a strong supporter of this activity. We more or less succeeded in demonstrating this principle, this concept, within the cardiovascular chapter. The only chapter that's really fully rendered in this respect and accommodated it at the SNOMED and ICD level is cardiovascular at this time. When Kent left, when SNOMED got a new CEO, and Bederhan Ustin stepped down at WHO, a lot of the old gang, so to speak, that was deeply committed to this, left the stage, and we're working to rekindle that in a way that we can complete this. There's no question that Kent and his colleagues were committed to making the changes and additions to SNOMED that were required to make this work, as WHO was correspondingly committed to making the changes in the ICD-11 scaffolding to make this work. We're still hopeful that that's the case, but we're dealing with a new cast of characters for the most part.
Yeah, I mean, I think Jim Campbell is still a kind of champion on the SNOMED side, at least. I hear him talking about it a lot.
Yeah, Jim has been part of the process, a very important part of the process in the common ontology creation.
Yeah, okay, thanks.
So it's just 5 minutes before the hour. I think that's all the time we have for the question and answers. So on behalf of Dr. Chute and the team at the BD2K Standards Coordinating Center, I want to thank you all for joining us and for your participation. And just have a great afternoon or in the morning for you West Coast people. Bye.
Thank you.
Thank you.